Now it's time to talk about the chi-square contingency test. And we'll start with the checklist, just, as we normally do. So the first thing on the checklist is that you have two variables, and each variable has two or more discrete, non-overlapping categories. So this is what distinguishes it from the goodness of fit test. In the goodness of fit test, we have only one variable. So we were counting the number of people who were male or female. That's still just one variable, right? Sex, male, female. In the second example, we counted the number of people in each GRE category. That's still just one variable, one set of observed frequencies for just that one variable. Okay, but in a case of a chi-square contingency test, you're going to observe people on two variables. Okay, so in the goodness of fit, you observe people on one variable. In the goodness of fit test, contingency test, you observe people on two variables. Very important. And then just like the goodness of fit test, your variables have to be discrete, so non-overlapping, and you need at least two categories. Now, similar to the goodness of fit test, you wouldn't want to have too many categories. If you have too many categories, you're going to end up probably violating that assumption of the expected frequencies being at least 5, right, in every category. So you don't want to violate that assumption, so you will keep the number of categories down to maybe 2, 3, 4. It really depends, because remember, you're not dealing with just one variable anymore, right? You're dealing with two. So if each variable had 4 categories, so variable A has 4, variable B has 4, that's actually going to give you 16 combinations. And you don't want to try and interpret 16 combinations. You'll see what I mean in a minute. In case you don't remember from the lab, you're going to understand this more in a second. All right, the second thing on your checklist, you, looking at your sample, you just observe or you count the number of cases, so the frequency, that fall into each category combination, right? So if it's 2 categories of variable A, 2 categories of variable B, that gives you 4 combinations, 4 cells. You just count the number of people in each of those cells. Now, you're trying to answer the question, is there a relationship between variable A and variable B? So that is a different question than the goodness of fit test, right? Because the goodness of fit test, you are answering one of 2 questions. One version was, are my categories evenly distributed across the different categories, right? Are my frequencies, let me rephrase that, are my frequencies evenly distributed across the different categories? Or in the second version of the SPSS test, you were asking, are my categories distributed the same way as some other distribution? Here, with the contingency test, we're asking the question, is variable A dependent on variable B? In other words, is there a relationship between my 2 variables? Another way you can say that is variable A contingent on variable B? To say that A is contingent on B means you're saying that A depends on B. That's what the word contingent means. It depends on. If something is contingent, it means it depends on something. Okay? So that's why the chi-square contingency test is called that, and it's also called the test of independence. Now, hopefully hopefully you're going to see that the chi-square test of independence resembles a two-way ANOVA. Specifically, it resembles a interaction effect in the two-way ANOVA. Because remember, two-way ANOVA, you had factor A and factor B. And one of the effects that you could test in an ANOVA, in the two-way ANOVA, was the interaction between A and B. And when there is a significant interaction effect, it means A depends on B, or the other way around, B depends on A. But you didn't look at frequencies to come to that conclusion. You looked at means, right? You wanted to know if the means in each of the cells changed in such a way to suggest that whatever effect factor A is having on the dependent variable, whatever effect factor A is having depends on factor B. So it's the same kind of thing with the contingency test, only instead of looking at means, you're now looking at frequencies. And then when you see that the pattern of frequencies is such that there is a relationship, then you can say that variable A depends on variable B.